All right, this is AP Calculus ABB, Unit 5, Lesson 5, Introduction to Volumes. We've been finding areas by dividing things into rectangles. So now we're going to be basically finding the volumes of rectangular prisms, right, which are thin slices. So I'll give you an example here. We could take a sphere, right, and we could divide it up by slicing it very thin into very thin slices. Imagine potato chips, right, into little discs, right? And we can find the volume of each disc and then sum up the discs. Or if we had a different kind of shape, we could have, say, a rectangular prism here, just to take a simple one. And we can find the volume of a slice, like a slice of bread, right? And then sum up all the slices. So that's the approach we're going to be taking here. Okay. So in this particular problem, I'm going to look at the graph, or the shape. I'm going to do, well, let me write this as find the volume of a solid whose base is the area between y equals x squared and y equals x, whose cross sections are semicircles. Okay, so let me see if I can sketch this for you. Give you a picture of what it's looking like here. 2, 4, 5. Call that 1. 2, 4, 5. Call that 1, and this 0. Okay, so y equals x is a horizontal line. Or not a horizontal line, a diagonal line. Diagonal. Okay. Y equals x squared goes through 0, 0, and 1, 1, but it is curved. Kind of like so. Okay. So there's the base, right? And then we're going to take that base and we're going to take slices, like slicing an orange, right? We're going to take a slice, and the cross-sectional area of that slice is a semicircle. So let me draw a 3D view here. Semicircle. Okay. Kind of like an orange slice, right? So in 3D, see if I can sketch this in 3D. Here, I'm kind of tilting the... Okay. It would have a shape, shape kind of like this, where all the cross sections are semicircles. Okay, if you can kind of picture that. Actually, that's, yeah. All right. Okay. So the strategy here is to find the volume of one slice. And this is delta x, right? Delta x, right? And we can express the diameter. The diameter is y equals x minus y equals x squared. So the diameter is x minus x squared. So the radius is x minus x squared divided by 2. Okay? And the area of a semicircle is 1/2 pi r squared. In this case, 1/2 pi times x minus x squared divided by 2 squared. Okay. Now the volume of this slice, is going to be the area times delta x, right? That's the prism effect here. We multiply the base times the distance through which it's pulled. So volume is 1/2 pi times x minus x squared divided by 2 squared delta x. Okay, and now we recognize this as a Riemann sum, right? And so the total volume is the integral from 0 to 1 of 1/2 pi times x minus x squared divided by 2 squared dx. Now, as a definite integral, I can evaluate this numerically, right, using my calculator. You can use your numerical integration function in your TI-84 or in Desmos. Just type int 0 to 1, 1/2 pi x minus x squared divide 2 to the power of 2 dx. Okay, and there we go. We get about 0.013. Not a very big area, but remember, this is a 1 by 1 square, and 1 by 1 by 1 would represent the volume. So what we're talking about is a volume that's very small, relatively. But what if we had to find the volume exactly, right? Could we do that? Well, to find the volume exactly requires integration by hand. So let's do that. Let's move this up here a little bit and find the integral. Okay. So we're going to move the constants out. 1/2 pi times the integral from 0 to 1. Square this. So squaring a binomial, x squared minus 2x times x squared is x cubed plus x squared squared, or x to the 4th over 4 dx. Let's move the 1/4 out. 1/4 times 1/2 is 1/8. So simplify a little bit more. Pi over 8 times the integral from 0 to 1 of x squared minus 2x cubed plus x to the 4th dx. Okay. All right, so let's integrate. So pi over 8 times the integral of x squared is 1/3 x cubed minus integral of x squared, x cubed is 1/4 of x to the 4th. So 1/4 times 2 is 1/2 x to the 4th. X to the 5th integral is 1/5 x to the 5th, so plus 1/5 x to the 5th from 0 to 1. And this is kind of convenient because any power of 1 is 1, unless it's to the 0. Any power of 1, any power, even 0, is 1. And when I insert 0, I just get out 0. So this is literally pi over 8 times 1/3 minus 1/2 plus 1/5. Get a common denominator, 30 in this case. That's 10/30. That's 15/30. That's 6/30. So 10 minus 15 is -5 plus 6 is 1. So this is pi over 8 times 1/30. Or we get pi over 30 times 8, 240. And let's see if that's accurate. Pi over 240. Yeah, there we go. 0.013. Okay, and that would be an exact value. Exact value, yay! All right, so you get the idea. So instead of doing slices that are rectangles, we do slices that are cross-section volumes, or cross-sectional areas. Multiply the area by delta x or delta y if you're integrating on y, and sum up all the slices. So we're just doing 3D slices instead of 2D slices. Right? That's a big principle in calculus.